Oi lads, it's Danny here today, bringing you lot a lovely video. In today's video, what we're going to look at is why the hyperbolic function of sine, why is that equal to this? Why is that? Well, before we jump into it, I want you lot to leave a like and subscribe, and let's get right into it then. So the first step that you lot are going to need to do is we are going to need to apply the Maclaurin series, more specifically the Taylor series at a is equal to naught, a is equal to 0. And this is the formula which we are going to use to basically represent sine h of x and e to the power of x and e to the power of negative x. So I'll show you in a moment how to do that. So let's write it, e to the power of x, let's represent it using the Maclaurin series as shown. So once you have done that, you are going to have this. And this basically represents, all these strings of numbers basically represent e to the power of x. And how do we get every single individual term? Well, that's very straightforward. What you are going to need to do is we basically f of 0, which is basically e to the power of x is 0, is going to be equal to 1. And then you do the derivative of e to the power of x divided by 1 times x, and then you do that so forth, and so, you do it for the next order, degree polynomial, and then you continue down that trend. And what you are going to notice is it's going to basically move like this, And likewise, we're going to do the same with e to the power of negative x. So the same thing applies. Instead, your function that you are going to be dealing with is e to the power of negative x. And as you can see, it basically is very similar to this. The only difference here is that you are going to have a negative after every second term. So that's basically it. And the last function that you are going to need to apply the Maclaurin series to is sine of h, which is your hyperbolic function. As you are going to notice, when you do that, the first term is going to be naught, and then after it's going to be x divided by 1 factorial, and then you can see the trend. So if we continue this so on and so forth, you are going to have plus 0, and then you are going to have x to the power 7 divided by 7 factorial. So you can see the trend, right? So once we have established this, what you are going to need to do is we're going to represent this equation using this Taylor series for each individual term. So let's do that. Once you have done that, you are going to have this. So this over here corresponds to sine h of x, and on the right hand side is basically 1 divided by 2. Remember, this is the scalar quantity. It's going to be 1 divided by 2. So we're going to move it outside the bracket. And what we're really doing is e to the power of x, this is e to the power of x, subtracted with e to the power of negative x, which is over here. And what you are going to notice straight away is that some terms can cancel out. What do I mean by that? Well, look at the 1 over here and look at the 1 over here. So you got 1 minus 1. That's going to cancel out, right? And likewise, x to the power of 2 divided by 2 factorial subtracted by the same quantity, that's going to cancel out as well. And then if we look at this term over here, the same thing happens, and so on and so forth. So we can basically rewrite this as the following. So the left hand side doesn't change. The right hand side, however, is going to be this: 2x divided by 1 factorial. So you got a minus of x divided by 1 factorial. So you got the same term being added with itself. So therefore, you're just going to have 2 times that term. And likewise, you do the same for x to the power of 3 divided by 3 factorial. You're going to have 2 terms, and so on and so forth. And notice we can basically, since we got 1 divided by 2 outside the bracket, and all these terms are going to have times 2, you can cancel out the 2's basically. And therefore, what you are going to notice is that the left-hand side is equal to the right-hand side. And therefore, that implies that this must be equal, and then we officially proved the hyperbolic sine function proof. So if you enjoyed this video, please drop a like and subscribe, and I'll see you later.